Thus far, we have seen that we were just restricting our simulation study to two nodes, that is tick and talk. But in order to make it more exciting, it is about time that we start considering extending the topology. And when the topology is extended, then the packet exchange does not take place onto a single communication link. Rather, it would be sent and received between different nodes. What we are interested in is, first, we extend the topology, and then we are going to randomly choose the destinations from random sources. This way, we'll see that the communication keeps on going and the packet gets tossed around different destinations. So, we'll start with creating several tick nodes. Why tick nodes? Because usually what we have seen is talk is only a responding node. The active or the load of the functionality has been done on the tick side. We are going to connect these tick nodes together, and we start with one of the nodes that initializes the packet sending out activity. The nodes which receive these packets keep tossing it around till it arrives at a predetermined destination. Here, for the sake of this particular study, we choose the first node, that is node number 0, to send out the message, and we choose the third tick 3 or the fourth node to actually receive the message finally to stop the overall session. For the sake of this module, please refer to ticktalk10 txc10.cc. When we look at the NED code here, we see that the gate is no more input and output. In fact, it is input in with square brackets, starting and closing square brackets, and output starting and closing square brackets. What does this mean? It means now we are not creating just one in and one out gate. Instead, we are declaring vector gates. So vector gates actually means that we are creating an array of gates such that each gate is assigned to a different tick node. That is, if we look at this particular code, here we see that the size of the vector is determined as 6. It means that the total number of gates here are declared as 6. Now, here it is a mundane job, but it has to be done anyways, that we are going to establish links between each out gate to another in gate. Here, we are hard coding it in a way that tick 0 out gate is connected to tick 1 in gate. Tick 0 in gate is connected to tick 1 out gate. And as you see, that the delay parameter is set to 100 milliseconds for all these connections. Now, we go to the C++ file. Here, we introduce a condition that when we initialize, after this initialization process, we call a function called getIndex. This getIndex retrieves the index value of the gate vectors. Only if the index value of the gate is equal to 0, it means this particular node, that is tick 0, is going to start the overall packet transmission session. The lower part of the code is already discussed. The handle message that we have earlier seen so many times has now been extended to introduce the choice of the destination. Again, it is hard coded here. That is, only when the index number, the index of the gate is 3, a message would be displayed as the message has arrived, and it is going to delete the message. If it is not the case, it means that the packet is still tossing around between sources and destinations, which have so far not included gate number 3. Here, we introduce randomness between the selection of a destination from any source node. When it receives a packet, it has to send out the packet. Where is it going to send out the packet is determined by a probabilistic phenomenon that we introduce here by using the concept of using two integer numbers. One is n and the other one is k. N is actually giving us the gate size. Here, the gate size is 6. So it means the gate size of out is going to give value 6 to n. And another variable called k, which is an integer, computes the uniform distribution as an integer value for anything between 0 to n minus 1, that is between 0 to 5. So it means there is a probability that when, as a random process, a sender determines the destination, it might as well be itself. So eventually, when this process is executed, the message would be displayed as forwarding message on port number, which is determined by k. The TK environment output for this particular situation is shown here. You see that here we have 6 nodes and the packet is currently traveling from tick node 4 to tick node 1.